Today we're going to talk about, we'll keep talking about some basic building blocks of JavaScript. We'll talk about stuff that most of you, whoever did any other programming language, again, knows how these things work. Those who don't, maybe a bit less. But we'll deep dive into them again. There's not a lot to say about most of the stuff that would be pretty similar to what you already know if you've used C#, for example, or Java or any other language. Otherwise, we'll cover it. We'll go through it maybe more quickly, but we'll cover it for sure. So we'll talk first about conditional statements, which are tightly coupled to logical expressions that we talked about last time. We'll talk about loops, which are tightly coupled to conditional statements. And then, unrelated to that, we'll talk about arrays and how they work with JavaScript. There are some maybe interesting, maybe not so interesting things to know about them. So we'll start with conditional statements. Wait a minute. No way. Conditional statements give you the option to make decisions in your programs. Yeah, if you have something you have to check. So that's the basic engineering flowchart. You know, if it moves, yes. Should it move, then you use either tape or you use WD-40. That's the two things that every engineer needs, and you can pretty much solve any problem with those. We'll start with the if statement. That actually what we saw in the flowchart is its incarnation in language. Gives you the simple condition, checking if something, if some condition evaluates to true, then it will execute statements in the block. One point about style and coding. We're using curly braces. They are not necessary, of course. You can omit them, but what we have here is a block, a closed block, a closure, if you want to call it. And inside it, we can put multiple statements. If you don't put the curly braces, of course, you can put only one statement after the if condition. So, anything you want, and if the condition doesn't evaluate to true, the moment the program hits the if, then this whole block will be bypassed. Okay? If there's some questions, if it's not clear, ask me. So what can the condition be? It can be anything. It can be a Boolean variable. It can be any logical expression. I think we saw last time that there are many things that evaluate in JavaScript to true and many things that evaluate to false. And it's pretty tricky. So you can put a string that contains something that will be evaluated to true. If you put undefined, it will be equivalent to false or null. So basically, anything can be evaluated when you talk about condition. And it can be, of course, a more complicated condition, a complex, which is made of different parts, different expressions that are tied together with logical expressions and logical operators. So again, that's the simple diagram that shows how it works. As a flowchart, we get a condition. If it's false, we're just bypassing and continuing. If it's true, we're going into the statement or multiple statement, and we execute them. One thing about notation and logical expressions, this is what's called the Yoda notation. This is something that's done also in other languages, and there are pros and cons to this type of writing. I don't like it. I haven't seen it in much of, let's say, industrial code. I've seen it online. Some people are using it. There are advantages and disadvantages to writing your conditions like this, because usually what you would do is put it in reverse. If your variable is equal to some constant or some expression. And if you reverse this, well, it could avoid some errors, because if the count, for example, would be something of a, could be a null reference, you could, if you have a null reference in the expression that you're trying to evaluate, this could fail. This could help avoid errors also in maybe in more strongly typed compiled languages, but I don't like it because it's not nicely readable and it's not it's not intuitive. So there are some supporters of this type of writing, and I'm not one of the supporters, but so that you know that this exists and it will work, but it's not common, and I'm not sure it's the best type of conditional statements. So let's see a quick demo. Okay, so it will be easier to read like this. Again, an HTML page, and we have two labels and two input text fields, and we have a button on click that would find the bigger of the two numbers that are entered. We have the JavaScript console that would read the two numbers, and here we have, so at this point of the program, we have a condition that enters this block if bigger, which is first evaluated to the first number, is smaller than the second. It's a little not very intuitively written, but we can see it, and it will, it tries to evaluate which is the bigger number. So the first thing we do is assign the first variable to the first number, assuming it's the bigger one. And if it's not the bigger one, what we're checking here, then we're assigning the bigger variable to the second one. And then we're just outputting with the yeah.
First thing is you are making the new function, or you're calling an existing built-in function, what within the early days?
You mean these two?
No, you're defining, it seems you're defining variables there, first, second, bigger.
Yes.
But on the upper line, get function on find bigger button 3.
Yes.
It's a function that you define, right?
This is the function. This is it. You see? This is this is the function. There's a trick here because you see the function is actually defined after it's being. It's not true because it's being called on click. So once the page, I assume that the page loaded completely before I click it, and then the function will be available. It shouldn't be put like this. I mean, the function, usually JavaScript functions will not be found in the body of the document. First of all, they'll be in the header, and they'll be in external files, and they'll be loaded when the page loads. So when the body starts to load, it already has the functionality. I mean, if I put some functions here that need to be called before this block is loaded, they'll have problems. But since I'm doing it on click, it's safe to assume that the page is loaded and the button is available to the user. And then when I click it, the function is already stored in the browser's memory and can be executed. It's not best practice what you see here, but it's good for the demo because you can see everything in one place. So, all right. I wanted to say something else, maybe. Maybe I'll remember it. Okay, so let's see this in the browser. Okay, the JS console, by the way, we've seen it last time. It's the it comes from an external JavaScript file here, and it writes lines into this div console. It's pretty easy to do. It just makes it easier for us to interact and write text into the console as if it was a real console. Yeah.
Sorry, last question.
Sure.
Can you explain a bit more in the function? You're defining a variable and you're calling a built-in function, and within the brackets you have an argument, or what? Can you explain
this one? Okay. I don't want them very much to get into the JS console file that we have, but I can show you somewhere that we are referencing this CSS, okay, but there should be also a JavaScript somewhere. Here it is. So I'm referencing this JS console file, which basically gives me an object called JS console, and I can interact with it. And one of the methods that it gives me is read float, and I'm giving it a selector. This is a selector similar to CSS selector. Also in jQuery used the same type of selectors. So this will go by ID. It will look for the element with TB minus first ID, which is this input. So it will read the text into it. It will parse it as float and put it into the first variable. So this is out of our this behavior is out of our scope, but that's what it's doing here. It's basically reading from this control the value, parsing it as float, and putting it into the first, and then into the second from the other control. Then we can use this JS console in order to write data into this black box. This black box that you saw in the browser is basically this div that's with the ID console. And it's just appending strings to it. All this is pretty easy to do. The advantage here is that we're using an object which is giving us from the external script file. And this object has those methods, and we can just call them and interact to make our lives easier. Is it clear now how it works? Pretty much. If you want, I can show you later the JS console file itself. See what's in it.
And this is usually a local file.
This is not usually anything. No, this is a custom for the demos. No. It's completely custom. I showed you last time JSFiddle, for example. I did something almost similar here, because what I did, I put a div here called results, and I made a small function here called writeLine. It's unattached to any object, but it's a function in the context of my script here, and I can just call writeLine and pass a string to it, and what it does, it just appends lines to my results, taking it by ID and appending lines. This is done with jQuery. So all these lines that actually appear here in the result pane are coming from the fact that I'm calling this method a few times. And the same happens here. When this function is called, it calculates which is the bigger number and then writes it to the console, just appends the text, which is this text here. It's not standard library. It's not unless it's using some standard library like jQuery, for example, to find the element by ID. So back to the demo. Put here 50 and 15. So when I click the button, the function is invoked. It will get these two objects. We'll have a whole session about interacting with the DOM element and jQuery. And when I click the button, my method gets invoked, and the calculation is correct. If we put minus, it should also work. All right, so every time I click, I'm going to append a new line to this console, which is just a div with a black background. Okay with this demo? More complicated, the if-else. So what happens if we want to do to work with two different blocks of code? One will be executed if the expression condition evaluates the true, and the other one otherwise. Of course, we can put many ifs, and we can evaluate different conditions every time. But once we get to the last one, it could be else, meaning if you wrote your conditions correctly, you haven't entered any of them. You can do if, and then else, and then if else, and then the last else will be the last fall. So that's how we have two different, a separation between the true and the false condition. So almost similar to the previous one, we got a condition. If it's false, Actually, it falls to the second statement, which is marked by else keyword. And if it's true, you know, what do you see? Yeah. So an example to an if else, we get a number again from the document, and we are evaluating if this number, if you divide by 2, gives you a 0 remainder. That means the number is even, so we log to the console it's even, otherwise we log to the console the number is odd. So either one of these statement blocks will be executed, either this or that. I mean, anyone who's programmed in any language knows this, how this works. Quick demo. Okay, almost the same as what we saw in terms of functionality. Some CSS, which is irrelevant here, the console CSS, and our console div here, and the external script here. And on click, we get to the function, which is here, doing the same thing, getting a floating point number from this element to this variable, evaluating it, and writing to the console either this or that. This is HTML basically appended into the console div. So again, 59. And if we put another number, we get another result. All right. Nested ifs. So things sometimes get complicated when you start nesting conditional statements, when you start nesting loops. We'll also see it a bit later when we talk about loops. Of course, everything can start getting into spaghetti, and you should really evaluate how you build your expressions and how you build your code. But of course, when you start nesting like this, when you have an expression up here, then the whole block will be, of course, bypassed. So you can check a big condition up here and then start checking for sub-conditions inside the nest. It's very common structure. Yeah. Like I mentioned, you don't need to use the curly braces, but I warmly recommend to use them. It's good practice and it's good styling. No matter what language you're writing in, it's always good to use them. There's, of course, the religion of either you're using Egyptian style, which is one is opening up there, and the other is down, like, you know, like this. This is the Egyptian style. Because they are, you know what they are. And the other one, I don't know what actually it's called. I don't know if it has a nickname. But otherwise, you can write them like this. Opening and closing, and they are aligned. It's style dependent. I don't think there's any preference. There's no more correct. Some people are religiously very supporting of one style and others on the other. It doesn't matter. But of course, always use curly braces. It gives closure. It gives your code structure, and it's more readable. It's better. And then you can also extend your code if you need to add more statements or different functionality. It's much easier to do it with curly braces, even if you have just one statement. Yes, if you're using just one statement in your evaluated expression area, then you don't need curly braces. It's the same with C#. Not the same with other languages, like I think in PowerShell you need to put in Visual Basic you need to put start, begin, and end. In C#, in those languages, C#, Java, JavaScript, you don't need the curly braces if you have just one statement. I mean, If this is just one statement, this will also be acceptable. But I don't like it. It's not good practice. Nesting is also something like we saw here. You can start nesting and nesting, but like I mentioned, you should be careful with your nested code because it starts getting spaghetti and a lot of nested stuff. It's hard to follow. It's hard to debug. It's not readable. And it's not nice. Make your code readable, no matter what language you're writing in. Give your functions and your variables names that are explanatory and good. We'll talk about functions, but for example, I believe that functions should have as much as possible a single point of return, not to start, returning here, returning there, breaking it here, blocking it here, starting loops and breaking out of them. Keep structures and keep entry and exit points to everything you do, and that also works for if statements and other conditions and loops that we're going to see later. Also, take into account the third bullet. It's important. If you start evaluating conditions, so like we saw here, the first condition gets evaluated, and otherwise we're skipping to the next. And we could have multiple if else, if else, if else. Put the more common conditions at the top, because they'll be evaluated, and if they are evaluated to true, your code will run, and then everything else will be just ignored, and the program will continue. Otherwise, you'll be evaluating and evaluating and evaluating, and your code will have to start checking each condition, so it could affect your performance. So put the cases you normally expect to process first, and then write the unusual ones that your program will reach if it has to. And make your code readable. Okay. If you don't take this with you, then I haven't done anything. So here's a nested if example. Notice that we're using the triple comparison here that we talked about last time. If this thing, then we log. Otherwise, so if the first is bigger, then we log this. So we're taking here the three different options. If they are equal, if the first is bigger, and if otherwise the second is bigger. Demo. I'm rushing through the demos and I'm going through the slides. But yeah, you know what to do. Okay. Same trick, same CSS, same JavaScript, same console, and same click button method. Reading two floating point numbers, and now we're checking if the first is equal to the second. Notice that we're using this, but that's okay, because actually what we're comparing here is two floating point numbers, and we can expect that these objects are of the same type, and we can just compare their value. But if you're comparing something which is more fluid, or you have in one of them string and in another number, you might want to use the triple comparison here to check, so that you'll make sure that your objects are really the same. But in this case, it's fine. So if they're equal, write this. And otherwise, write if the first is bigger, then write first is bigger. Otherwise, if all failed, it means that we've passed through here, and we've fallen into this condition, and we check this one, and otherwise, we've fallen into this one. We could have streamlined this structure. We'll see it in a second. Yeah? This? Div. HTML. You don't know div? Okay. Yeah. Okay. Okay, I'll give you 2 words about div, maybe 3. Div is just a block. In HTML, there are many elements that are just blocks of containers for other elements. Div is one of them. So in a div, you can pretty much do anything you want. You can put text, you can put other control. They're just containers. There are 2 main containers which are used in common HTML. One of them is called div, the other one is called span. They're almost the same. They are the same, but they have different default behavior. Div is what we call a block container. So it can have a height and a width, and you can put in, and it will by default get some size into it, and it also blocks lines. So when you put a div, everything above will be above, and everything below will be put below. It's a block element. It blocks both lines from above and below. Span is an inline element, so you could put it, and things will not by default break. They'll continue, and they will flow. They'll have a flow, and they will not break lines. Span also doesn't have its own by default height and width. So if there's nothing in it, the span will be just collapsed by default. But they are the same, because if you change the styling of one, they can behave like the other. You just put display block, then span becomes div. In more advanced HTML, HTML5, there are other elements that are used, which are semantic, like nav, navigation, or I don't know, something else that I forgot. But those are basically the same. They are just containers, and they are like header, footer, navigation. They are the same. They are just empty containers, and they are used to give your page a semantic structure, so it could be understood. But basically, they're all the same. So here, yeah, this div element starts here and ends here. You know how HTML is structured with tags that open and close. So that's the opening tag. It gives it an ID, and here it's closed. Notice that up here there is a JS console CSS. And just to show you the dev tools in the browser, and I'll just select this div console. And you can see that I have some styling that comes from the JS console CSS file. It gives it margin, padding, background color, width, and height. So this is the behavior of this div as we see it on screen. Yes, this is the console div. And the function in the background of the JS console JS file just takes things and appends lines to this, just lines of text. But is this a demo we're looking at? Nested if else. Something is wrong. Yeah, I just think this is wrong. The word's odd or even, right? Yeah. It should say something like better. Okay, so let's type here 48 and here 13. 48 is bigger, or 113, or 48. So that's how the conditionals work. As I mentioned, we have nested here, which basically we don't really need. We could have written it as 3 different if-else. So it could have been written like this. So I'm taking this if here. Now we have too many opening. So here what we have is 3 different conditions which are evaluated one after the other. The idea of nesting the second 2 is that if this one worked, then we don't need to evaluate anymore, and we skip the whole thing. We don't even try. Otherwise, we are checking either this or that. So this should also work. Yeah. So this is also a matter of style. If you want these things to nest or not, you have to think about your performance. You have to think which code blocks will be hit and which ones will be executed and when. And that's really up to you, because you are developers and that's your job. And if you want to keep your job, do it right. Multiple if-else is just what I showed right now, that you can have multiple conditions which are not nested, but they are just going one after the other. Then they get evaluated. You can do a if, and then else if. Basically, like I said, you can have one statement. If you don't put curly braces here, you have one statement coming up. And what we have here is else. How to show it to you. So this is one if, and this is the else. And the statement of this else is one statement, which is this if. You understand what I'm trying to say?
Why the first one is in brackets?
Because what we have here is, in this case, it doesn't matter. If you put brackets here, you'll actually make it nested. And that means you can add more ifs like we saw just now in the example. But if you don't put them, then you will have if, they'll just go one after the other and they get all evaluated. And there's no block which is, let's say, bigger or less important that can get completely wiped out. So it's a matter of style and it's a matter of requirements of what you need and how you need to implement it, and that's up to you. We just saw a live demo of this, but maybe we have something else. Oh, come on. Sorry about the examples being so boring. Still better than the IT conference, right? So, check numbers button click. Actually, this is not about numbers at all, and I think this shouldn't be called order even at all. It means check letters, check vowels or something. So here's a good lesson for you. Don't copy paste. Be careful what you copy paste. So what we have here is multiple checks that we're doing on the text, which is entered into the text box. So quickly to review this, we're getting the text, and we have three counters, three variables here, vowels, others, and numbers. And we are going through the text. We'll see textual functions in the next session, not today. And we have a loop. We'll see loops later today. And we're reading the text character by character by this loop. Every time we take one character in the iteration, and we check, for example, if the character is a lowercase a or character is an uppercase a. Otherwise, if the character is e, then we are incrementing the right variable that holds the information. Otherwise, if the character falls between 0 and 9, then we increment the numbers. And otherwise, if we haven't fallen into any of those conditions yet, we increment the others. Which, by the way, if your string contains space, it will also get added to the others. And then when it's done doing the loops and counting all the characters, it goes to the console and it prints out how many vowels, how many numbers, and how many others. Yeah, check. Maybe better. So if we put some text here, we get evaluated on each of those. We talked about multiple conditions that could be either nested in each other or they could be one following each other and they're chained one after the other. When we have multiple conditions, we'll can also use switch case. Again, anybody who's written any normal, real world, modern language will know how to use switch case. But how does switch case works? Suppose you have some statement, some expression you want to check. You can put it in a switch, and then we have a whole block of cases. We are just checking if this expression is equals to one of those cases. Now, there's a tricky part here, because if you start going by cases, they start falling down into each of those cases, and they'll get checked and executed. So, and eventually we'll have the default, which means that we haven't fallen into any of those cases, meaning the expression here is not equal to any of those other cases along the way. Then we get to the default, and the default one gets executed. Basically, what we're saying here is if day is equal to 1, then log to the console Monday. If it's equal to 2, log to the console Tuesday. If it's equal to 3, log to the console Wednesday. And otherwise, or by default, just call console log error. The reason we have here all these breaks are to break out of the structure of this enclosed switch checkup. That means that we don't want to check any more conditions, and we don't want to get to the default condition. So every time we check, we execute the right statement, the right collection of statements, and then we break out. So this is being executed serially from the top to the bottom, and every line here will be checked. And once we get a match, we execute all the statements, and we don't need to put them in curly braces, because they are going to be executed all at once, I mean, one after the other anyway. Yeah. Structure, style. If you have multiple, if you have an expression you need to check, and you have multiple, if this is equal this, else, if it's equal this, else, if it's equal that, it's much more. It's not like nested structure. It's like the if else that we saw, which are coming one after the other.
Maybe my question wasn't correct. Which is better if I have few conditions to use Ifelse, if I have more code to use switch case?
Switch case doesn't work for every if condition. If you have a condition to check which is complex, you cannot put it in switch case. Switch case means if this expression here is equal to this, or it's equal to this, or it's equal to that. If this is your case, if that's what you're trying to build, and you have multiple such conditions, and you want to evaluate, just like here, like I want to check which day it is, and check by number, and write the name of the day, then you can do it like that. If you have more complex if structure, if your conditional statement is more complex, or if it doesn't fall into this paradigm, you don't use switch case. But theoretically, what we could take this code, and we could basically transcribe it. So it would be something like if day is equal to 1, then do this, and then we'll just change it like that. So this could replace a whole chain of if-elses. If this is what your code looks like, then you can change it into a switch case. More elegant, better structured, more efficient, but doesn't work for every structure. Okay, and here, the last one will be the last else. So this is how this can get transcribed into if-elses. So the break here, the word break is a precaution, because if you build it like this, you will not need it, because it will get evaluated, and then the first statement will get, and then you will evaluate the second, and then otherwise it will be evaluating running the second statement, and so on. if you don't put the word break here, you'll keep evaluating down, down, down until you fall to the default. So good structure is to break out, even if you don't get into any of the other conditions. Marto, do you remember what's the name of the other style of curly braces except the Egyptian style? If you put them in aligned? I mean, if they're not like this, but they're like that. Yes. Style, coding style. Bulgarian style. I don't want to see the Bulgarian style. So, how switch case works, evaluating the expression and checking the constants which are specified in each of one of those cases. If you get a match, then the statement or a number of statements are executed. And in case you haven't gotten any execution so far, and you've fallen down all the way to the default, and you haven't broken out from the structure, and you're lucky to get there, then the default will happen. Quick switch case. I have a feeling it will say odd or even. Ah, it's not. Okay, so button check the day. The same console that we've seen. And the second console.js that fills it. And then we have the function. We are reading from the console. This time we're reading an integer. This is again a helper function which is coming from our JS console JavaScript file. But if you really want, I'll show it to you. And we have a variable day which is here uninitialized. It's undefined at this point. Excuse me, but my eyes hurt. Okay, so evaluating the day, which should be a number, and assuming that we are validated to actually a number, an integer, we're checking each of the cases. If it's 1, we'll write Monday, and so on until we reach the default, which means we haven't fallen into any of those equations, and we'll write invalid day otherwise. Okay, pretty simple. If we put a number which is in the list, and if we put a number out of the list, I wonder if it has a good validation. Okay, that's good. Okay, maybe since this is the last of our demos for this topic, I think. Didn't load the file. And didn't save it. Okay, that's better. So just to go with the flow, putting a breakpoint here to see. Just to show you once how the things work in the back. So we get our variable here, which is currently undefined, but after the execution of this line, it gets the integer from this element. By the way, hover over and you can see the function signature and where it's coming from. So we get the day with the number that I just entered. And now we go to the switch case, and we have fallen through all the cases to the default. And now writing the string to the console. Notice that I also like the fact that here we're writing to the console only after we've evaluated and constructed our string. We're not putting a write line in each and every one of the cases, meaning first take care of your data, put it all together, get your string right, and then when you have it ready, just throw it. Have one point of execution. Don't repeat yourself. We talked about the false-like conditions, about things that evaluate to true or false. So I put a link here, which I don't remember, but I'll open it to see. Yeah, so there are all kinds of things that evaluate to true and to false in JavaScript. Of course, if you're good developers, and you are, you'll use conditions and you'll don't get this. You will use the right. You'll use actually booleans, and you'll use expressions that really evaluate to true or to false. Don't fall into all kinds of empty strings and nulls and zeros. They're all correct and they're all okay. And I'll remind you the other example that I showed you. This one. So first of all, it's good to use triple comparisons when you need, because really true will be really true and one will be really one, and you'll have your conditions correct. And the second is that all kinds of things can evaluate to all kinds of things. Yeah, so strings with the number 1 can actually evaluate to true, and arrays can also evaluate to true, and so on and so forth. So be careful with what you put in your conditions, because true can be evaluated from all kinds of different truths. We have a demo, except this one that I showed you. Maybe not. Or maybe that's what I meant. Okay. Okay, that's an old joke about a conditional statement. Yeah, go to the supermarket, buy 1 milk, and if they have eggs, bring 6, and comes back with 6 bottles of milk. Very funny. I think that's our sign to take a break.